talked to surface area, prisms, and cylinders. Two main ideas today with cylinders and prisms. Remember, surface area is the area of all the pieces that make up the figure, and the best example I can give you is wrapping paper. So imagine wrapping a prism or a cylinder with wrapping paper. You have to figure out how much wrapping paper there is. So you'd find the area of all the pieces on the outside and add them together. That's the general idea. A prism, it's a polyhedron with two congruent bases connected by rectangles. This is an important idea that you know what a prism is, because if you don't know what a prism is, you're not going to be able to find the surface area of it. Two congruent bases connected by rectangles. So the surface area of any prism, we have two congruent bases. The general idea is to find the area of both those bases and multiply by 2, because there's two the same, and then add the area of all the rectangles that connect the sides. So this is the general idea for finding the surface area of any prism. On your formula sheet, and also surface area includes units squared, don't forget about that in your answer. On your formula sheet, these are the formulas that you would be using for today. This formula on your formula sheet is very generalized and it'll work for any prism, but to be honest, I think that it's easier just to find the area of all the surfaces, which is what I'll show you in a minute. We have two ideas here, surface area and lateral area. Lateral area is only the sides. It does not include the top and the bottom. So the bases are not included in lateral area. And that should make sense if you look at the difference between these two formulas. This one's surface area, all the pieces that make up the figure. Lateral area is just the rectangles. P in these formulas is the perimeter of the base. In the picture here, the bases are triangles. They can be anything. They can be octagons, pentagons, any kind of shape. Capital B is the area of the base, and again in this picture that base is a triangle. You'd have to find the area of the base, multiply by 2, find the height, and then multiply that by the perimeter of the base. The height is always up the side of the rectangles. It's always sitting on the base to find the height. And this works for any prism. This formula is also on your formula sheet, and it works for any rectangular prism or a cube. A cube has all the same lengths. Your length, your width, and your height would all be the same. Rectangular prism, length, width, and height doesn't matter what you pick for L, W, and H as long as you're consistent through your problem. It's a relatively easy problem. Look at this first problem here. We're asked to find the surface area, and this is a pentagonal prism. This is a good example that you see what a prism looks like. So we have a pentagon here. We have a pentagon on the back side, and then hopefully you can see that it's connected by how many rectangles? How many rectangles are in this picture? There's 5. There's 2 here, there's 2 that are kind of on the sides, and then there's 1 on the bottom. So there's 5 rectangles and 2 pentagons. Asking to find the surface area of this, we have to find the area of those 2 pentagons, and then the area of all the rectangles. So let's start with the bases first. So we have 2 bases, and they look like this. And this is the information that's given to me for that pentagon. Have we ever found the area of a regular pentagon? Yeah. We have, we just learned this. So just given a side length, I need to find that central angle, 360 divided by 5, that gives me 72. And then the triangle that I'm concentrating on looks like this. Half of 72 gives me 36. This side is half of that side, so this is 1.5, and I have to figure out my apothem. Remember that formula is 1/2 times the apothem times the perimeter. So this scenario is our tangent. A tangent of 36, opposite over adjacent. Be careful with these problems when the variable's in the denominator, you have to get it out of the denominator. I think they've had a lot of people making mistakes on this and just saying tangent of 36 divided by 1.5, which is not correct. Think through your problem solving and your equation solving skills. We have to get that out of the denominator first before you start solving. So if I multiply both sides by A, I get A times the tangent of 36 equals 1.5. Now I can divide by the tangent of 36 to get A by itself. So when I plug this into my calculator, you should get A as 2.1. So again, that's our apothem. My perimeter, each side is 3. We have 5 sides. Our perimeter is 15. Somebody have their Desmos out for me, help me out here. So our area of two of these figures, two pentagons, the formula is 1/2 times the apothem times the perimeter. Now we know that 2 times 1/2 is 1, so don't waste your time putting that in your calculator. I need 2.1 times 15, what does that give me? You got that for me?
31.5.
Thank you. So this is just the bases. I want you to see how I'm showing my work, the two bases. We have 5 rectangles. What's the dimensions of each of those rectangles? They're all the same dimensions.
3 by 11.
Exactly. The easiest one to see on this particular problem is the one that it's sitting on. It has a 3 here and an 11 on this side. So we have 3 by 11. To find the area of these rectangles, we have 5 of them, and they're each 3 by 11. So what's the area of those? Should be 165. So total surface area, we're adding everything together. So total surface area would give me 31.5 plus 165, which gives me 196.5 centimeters squared. Now, if I was asked to find just the lateral area, I would just find the area of these rectangles. Remember, lateral area does not include your bases. So you would just not do any of this, and your lateral area would just be 165. So we can say lateral area, 165 centimeters squared. Okay, moving on to a cylinder. So a cylinder, I want you to understand the actual formula. This is what the book tells you. 2 times the area of the base plus the circumference times the height. That seems really complicated. So if you think about a cylinder, let's think about flattening a cylinder out. So if I flattened it out, it would look kind of like this. We have 2 bases that are circles, and then if I open this up, kind of like a soup can label, it would be a rectangle. Well, we know that a surface area is the area of all the surfaces. The 2 circles are pretty straightforward. But to find the area of this rectangle that would be like the soup can label, this height is pretty easy for you to see, I hope. That would just be the height up the side. But I want you to see that the other part of that rectangle has to match up with the circumference of the circle. Because when you fold that around that base, this area on the circle, the edge of the circle, has to match up with that soup can label. Okay, so this is a circumference times the height. That's where that comes from. So this is what the book is telling you here. Circumference times the height is like the label, the side part, the lateral area. This is 2 of the bases, and the bases are circles. So taking that forward to what you see on your formula sheet, it's 2 pi r squared plus 2 pi rh. Pi r squared is an area of a circle, and we have 2 of them. That's your 2 bases. That's these 2 here. Circumference times the height. Well, circumference is 2 pi r times the height. So this formula should make sense to you. Lateral area is only the sides. The lateral area for a cylinder is like the soup can label, the rectangle that I had drawn up there a minute ago. So if you look at this formula, you're taking out the bases. This is your bases. So your lateral area is just that second part, which would be your soup can label, the sides part. So using this kind of idea, let's find the surface area of this cylinder. What's my radius and what's my height? Radius is 8, or is 9, right? Because it's halfway across. So radius is 9, the height is 12. When we plug this in, first part's pretty easy. Just substitute. Now I want to do this so that you can show an exact surface area answer. Very similar to the way we found exact circumference and exact sector area. When I do this, I'm going to leave that pi symbol alone, just like any variable. So when I multiply 2 times 9 squared, I get 162. Over here, I'm going to multiply 2 times 9 times 12, which gives me 216 pi. Again, I'm leaving that pi there. I'm kind of dragging it with me. Now I can treat this like as if I was doing 5x plus 2x. We would add the 5 and the 2 and just keep the x with it. This would be 7x. Same idea over here. I'm going to do 162 pi plus 216 pi. That gives me 378 pi. This is my exact surface area. I'm leaving pi in it. Now, if you wanted a rounded answer, which I believe this is the way the book asked you to do it, you would get, which is approximately equal to 1,186.9 meters squared. This would be meters squared also. So what if I asked you for lateral area of the same figure? I already have everything here. What's the lateral area? Only the sides.
2 pi 9 12.
And can you see from there? So the lateral area would be?
216 pi.
Yep. It's only the sides. So the lateral area would be 216 pi meters squared. So it does not include those two bases. Okay? Okay, moving on, I have one more problem for you. Find the radius of a cylinder with a height of 5 feet and a surface area of 208 pi square feet. We're going to start by writing our formula. Just like any formula, you have to be able to use the formula no matter what's given to you. So 2 pi r squared plus 2 pi rh. When we plug this in, we know that the surface area, I'm going to take out surface area and I'm going to plug in 208 pi. On the other side, I don't know r, but I'm going to leave that in so I can solve for r. I know the height is 5. All I did was use the formula, plug in surface area, and plug in the height. I'm going to figure out what the r is. So my first step is to start simplifying, start pulling things away from that r. I'm going to divide everything by 2 pi. Each of my terms, I'm going to divide by 2 pi. When I do that, I get 104 here, r squared here, because these cancel. 2's and the pi's cancel, and I have 5r there. This starts really simplifying things very quickly. Because I suspect that I may have to factor, I'm going to move everything to the left. I used the quadratic formula to solve this because I didn't feel comfortable using 104 and trying to factor it that way. I'm going to cut this video short, but I do have my quadratic formula in my notes, so take a look at that and try that. The radius ends up being 8 feet.